Now we are going to see chapter 2, Logic Gates. Logic gates are the devices used as basic building blocks of all the digital circuits. It is an electronic circuit having one or more inputs and only one output. The relationship between input and output is based on certain logic. Based on these logic name is given, for example, and, not, or, etc. Truth table. Operation of logic gate can be best understood with the help of a table called truth table. It consists of all possible combinations of the input and the corresponding state of output of logic gate. Boolean expression. The relation between input and output of a gate can be expressed mathematically by means of Boolean expression. First we see classification of logic gates. Logic gates are classified into three types. One is basic gates, universal gates, and the third one is derived gates. Basic gates are not, and, or. Universal gates are NAND, NOR. Derived gates are XOR, XNOR. First we see NOT gate. The input is A and the output is B. If you see in the truth table, when we give 0 input, we get 1 output. Similarly, when we give 1 input, we get 0 output. That is, while writing Boolean expression, we write B is equal to A bar. So, the gate implements the Boolean NOT function where the output is the inverse of input. Next, we see AND gate. There are two inputs A and B and the output is C. So, in this truth table, if you see, if both the inputs are high level, then only the output becomes high. All the other condition, the output becomes 0. So, Boolean expression C is equal to A into B. Therefore, the gate implements the Boolean AND function where the output is logical 1 only when all the inputs are logical 1, that is high level. Then next we see OR gate. Here there are two inputs A and B, output is C, and if you see in this truth table, the output is high level when any one of the input is high level or all the inputs are high level. So the Boolean expression C is equal to A plus B. The OR gate implements the Boolean OR function where the output is logical 1 when any one input is logical 1, that is high level. Universal gates. Why they are called as universal gates? AND and OR gates are called as universal gates because it is possible to implement any Boolean expression with the help of only NAND gate or only NOR gate. Hence, user can build any combinational circuit with the help of only NAND gate or only NOR gate. Now we see NAND gate function. C is the output and A and B are the inputs. In this case, if you see, if both the inputs are 0, the output is 1. If any one put is high level, at that condition also output is 1. And if both the inputs are high level, at that condition we are getting 0 output. That is, NAND gate is the complement of AND function. C is equal to A dot B whole bar. The NAND gate is an AND gate followed by a NOT gate. The output is logical 1 when one of the inputs are logical 0. The next we see NOR gate. Output is C, inputs are A and B. In this, if you see the truth table, when all the inputs are 0, the output becomes 1. Other condition, the output becomes 0. The Boolean expression C is equal to A plus B whole bar. Now, what is NOR gate then? It's the combination of OR followed by a NOT gate. The output is logical 1 when all of the inputs are logical 0. Now next we see derived gates. It is also called as special purpose gates. Logic gates, which although they are not a basic gate in their own right, as they are constructed by combining together other logic gates, their output Boolean function is an important enough to be considered as complete logic gates. These two hybrid logic gates are called as exclusive OR gate and its complement, the exclusive NOR gate. The exclusive OR gate, XOR gate. Here in this case, if you see, if the input is, if A is equal to 0, B is equal to 1, the output is high level. If A is equal to 1, B is equal to 0, the output is high level. If both are 0, both are 1, in that case we are getting 0. So C is equal to, that is output C is equal to A bar B plus A into B bar. That is, the XOR gate produces a logical 1 output only if its two inputs are different. The inputs are the same, the output is logic 0. In general, an XOR gate will give an output value of logic 1 only when there are odd number of 1s on the inputs to the gate. If the two numbers are equal, the output is 0. The exclusive NOR gate. Exclusive NOR gate, if you see the truth table, when both the inputs are 0, the output is 1. If both the inputs are 1, the output is 1. If odd number, like if one is 0 and another one is 1, the output is 0. So if you see the Boolean expression, C is equal to A bar B plus A into B. The XNOR gate produces a logic 1 output only if its two inputs are identical. If the inputs are